be a total destruction, or small nuclear weapons are provoking more and more loading of nuclear weapons in submarines and so on. So I think that international treaties are crucial for global stability. I'm not against the whole. I am absolutely the critic of the NCT for not having indeed this huge technological evolution of nuclear. Thank you.
Ms. Rennes, you'll.
Okay, appreciating the limited amount of time, I just want to thank you again for inviting me to be on this panel. I think we addressed a wide range of topics, but it was interesting for me to see how much they overlapped. And actually, I took a lot of notes. It gave me a lot of food for thought, and the perspectives of the different participants really broadened my perspective as well. So thank you for that.
Yeah, when she introduces us, I'll mute it.
Thank you.
So.
And Mr. Roth.
So I want to emphasize two things. One is nuclear security is important because of the issues we've been talking about this morning, which is there are constantly evolving threats that nuclear operators, states, and international organizations need to keep up with in order to prevent what would be an international catastrophe, nuclear terrorism. But the other thing that I want to mention, just connecting to what we were just talking about, is nuclear security is also foundational to the non-proliferation regime. All three pillars of the Nuclear Non-Proliferation Treaty are supported by nuclear security activities. We can't expand nuclear power in a safe way unless there's strong security for nuclear facilities. Nuclear disarmament won't be possible unless the materials that are separated in that disarmament process are well protected. And non-proliferation won't be possible if security isn't provided for nuclear facilities around the globe. So I just want to emphasize that that this is, while not specific in the NPT itself, nuclear security is a practical foundational element of the non-proliferation regime.
I could not think of a better way to close this particular panel out. I want to express our appreciation. You've absolutely achieved what we were looking for. And as all of you know, we could probably talk for another 6 hours just on these subjects alone, because there's a lot to talk about. But you have stirred the pot of thought, not only amongst us, but I'm sure amongst all of our participants. So I want to thank you for one, taking time out of your very busy schedules, and two, engaging and not just providing the position of whatever government or organization, but you've actually engaged in the discussion. So thank you very much. Ladies and gentlemen, what we are going to do now, though, is as our agenda shows, we are going to allow our gold sponsor a chance to do a live demonstration. H3D will start its demonstration at 16:50 for those of you on Central European time, so in about 3 minutes, 2.5 minutes. For the rest of us, while you're listening to the demo, there's a chance for you to ask questions even through the demo. So please leave this portion of the venue out of the conference room and go to the demo room and watch the live demo. Ask your questions in the chat function on the side, and we'll get to them as fast as we can. After the demo, you'll have about 15 to 20 minutes to explore the exhibition hall and those that have some other industry partners that have brought information for you. We will reconvene at 17:30 Central European time or 12:30.
Okay, I guess it's start. Or I'll wait until a few more people trickle in at 10:50 before I get started here. Like we should have music or something playing instead of
Some elevator music.
yeah. Okay, looks like we just got to go ahead and start. Thanks everyone for joining to watch this live demonstration. As I'm sure you might have seen some of our banners, we're H3D, and we make gamma radiation detectors, specifically gamma imagers. Our flagship product is the H series, and it's this big, and it's able to achieve less than 1% energy resolution, which is pretty awesome for being only like under 10 pounds and able to be transported in the field or used pretty much anywhere that you need to measure radiation without having to like have a cryo cooling system hooked up to it. It's just ready to go within 2 minutes after turning it on. So it's really nice for having that high energy resolution, but without any sort of extra equipment or sort of maintenance issues that goes along with it. And so we use some of this technology. It's cadmium zinc telluride. It's it's not a scintillator, it's not a gas detector, it's a semiconductor. So our detection methods make it a bit more robust for being in the field. And it's really, really easy to operate. You can use it with the tablets that we send, but you can also connect it to it with your phone or your computer. And right now I have one of our H series systems. It's currently set up in this room, and I have the tablet connected to it. This is our interface. The best way to show you how it works is just to get started. So I will press the circle button to start a measurement. You give the measurement a name. It has a laser rangefinder that triggers, and it can tell you how far away you are from your source, or at least your point of interest. And then this is the screen as it develops a radiation image. Sorry, it's a little blurry and mirrored, but as you can see, it's a radiation heat map that's slowly converging as it detects more counts from the radiation source. And this image will come together. You have the energy spectrum here, so as you can see, the peak for cesium-137 is very high, and it stands out from the rest of your spectrum. But if you did have other unidentified isotopes, you'd be able to see the peaks pretty clearly on the spectrum and try to make the best guess for yourself if the system couldn't detect it because you didn't have the isotope in your library. These detectors can do pretty much all of the NDEF library isotopes. It's just a matter of what you load onto the system. So as we get more and more into this measurement, the cesium source is developing. So this is just a small little check source that we have in our office, and that's sitting on the table in front of the camera. But if there were other radiation sources, you would be able to see them as well by filtering the different isotopes. So I didn't have to do anything to this detector for it to automatically detect and identify cesium-137. I just started the measurement, and it went from there. So essentially, I know that there's some detectors where you have to go into special modes or maybe play around with some of the settings. This is pretty simple. All I had to do was just start it, and I was able to get all of this information. Other isotopes, you can select which ones you want to view. None of these are in the room, so I can't really show them to you, but you can do it simultaneously. So I don't need to do a separate measurement for cesium. I don't need to do, like, if there's cobalt in the room also. This would all be recorded simultaneously, and you can view them separately or together, but we generally don't recommend that. And so all of this information is viewed on the tablet, and at the end of a measurement, you can take the information out and put it in our post-processing our software called Visualizer. So you can do a few things with it. You can create a high-resolution image. So that would be an image where this cloud looks a little bit finer than it is right now, so a more precise location. We also have a software called SourceTerm, which is very similar to some of the other maybe quantification softwares you might have heard of, but it's got our own twist on it using our measurements, our detection capabilities, where you can model the geometry, shielding, basically the whole area that the source is in, and find the actual activities of these radiation sources while you're doing it. So just again to kind of show how easy this is, I stop the measurement, the screen turns black, and I can just start a new measurement by just doing the same thing. I press the circle button, and pretty fast and easy. And I don't really think there's too much else to that to show you guys for how this works. Right now, I only have cesium in the room. We had another source, but I couldn't really, it would have taken about 5 minutes, and I didn't think that was as interesting to show. And there's, just generally, this is pretty self-explanatory with how to use. Sorry about that. All of the different features. There's really not much training. When we do training on these, which is included with a purchase, it's pretty self-explanatory. You can see like the power, the temperature load, there's dose rate, and a bit about the image quality down here. So it seems pretty straightforward. Is there anything else that you think would be worth talking about?
I think we're okay. If anybody has any questions, we'd love to hear from you and answer them, but I think that's the main overview, unless you want to talk about some of the settings, but that's dependent on use case.
Yeah, I don't think that there's too much really to generally talk about the settings. But yeah, this is our H-series system. We also have a variety of other systems as well. We have a shielded solution. So if you're in a high radiation area, we have one with a tungsten collimator around the detector. We have a permanent mount spectrometer, and we also have a customizable module. So it's this small little box that has all of our detection crystals on it, and you're actually able to put it into any of your vehicle mounted systems, like on a drone or a robot, and have our detector go around in your facility, but for a much lower price and a smaller package than this. So yeah, if anybody has any questions, otherwise might just be standing here for a few minutes, or you guys can go browse the other booths and everything. And thanks again for stopping by and listening. I'd love talking about our technology, and you guys will see us at NCT USA and Europe. So stop by our booth if you want to get your hands on this in person and see how it works for yourself.